All right, let's look on this topic on the composition of two functions, the more advanced ones. The idea is when you do a composition, f composed with g of x, which we know is f of g of x, then two things can happen for the domain. We know that g of x must be defined, and the whole overall composition of f g of x must be defined. So when we say define, remember things that are undefined are things that make the denominator 0, negative square roots, but you have to look both for what you're plugging in, so your inner function, because you can't plug in an undefined value, and your entire overall composition. So when I'm looking at these, our first one we have a quadratic and a square root. So right away, I know the two big functions that give us problems are square roots and fractional kind of problems, where I have something on top, something on bottom. Those are the two main ones so far in this class that we have had trouble with. So if I'm doing the composition, f of g of x, I'm going to plug everything in from g and put it in for x. Now this is why this one's a little deceiving, because when I plug in the square root of x minus 6 for x, I get square root of x minus 6 squared minus 1. Now the square and the square root will cancel out, leave me with just x minus 6 minus the 1, which is x minus 7. So when I look at this final result, it's somewhat misleading because x minus 7 is just a line. There's no square roots, there's no fractions, there's nothing to worry about at all. So the f composed with g part is fine. It's defined for all x. But we also have to look at this g of x. Now g of x was the square root of x minus 6. Now if I put a value in here, let's just pick a random value. Let's pick 2. So if I put 2 in here, I get the square root of 2 minus 6, which is the square root of negative 4. That's no good. That's an imaginary number. That is not defined in the domain. So square roots have to be positive. So the smallest number this could be would be 6. So this one has to be basically x bigger than or equal to 6. So we'd write that as 6 to infinity. So I have to write not only have to check the overall answer once I've done the composition, I also have to check the function I plugged in. And that's typically the hard part, making sure you check this g of x that you plugged in. So let's look at this one. Now this one we have basically two quadratics. So again, I'm going to plug this g of x in for x here. So it's going to give me x squared plus 3 squared minus 2. So if I FOIL that, because when I square something, remember it's going to be FOILed. So x squared plus 3, x squared plus 3 minus 2. So that gives me x to the 4th plus 6x squared plus 9 minus 2. And I just did the FOIL there, first, outer, inner, last. And I end up with x to the 4th plus 6x squared plus 7. Now, there's no square roots, there's no fractions, there's nothing on the bottom. So this one is fine. So the f composed with g is fine. But remember, we also have to check what we plugged in. So we have to check the composition, which is fine, but we also have to check g. Now g in this case is just x squared plus 3. Now there's no fractions, there's no square roots, nothing funny in x squared plus 3, so it's good for all numbers as well. So this domain is going to be everything, negative infinity to infinity. The final answer was fine, and the g function that I plugged in, also fine. Let's look at this final one. We have x minus 6 and x plus 3. So again, I want to check the total composition and I want to check g. In this case we have different letters. So I want to check g composed with h of x. I want to see if that's okay. And I want to check h. It's always the second one you check. It's always whatever you're plugging in. Because our composition, we're going to plug h in for all the x's. In this case, there's 2. So g composed with h of x is going to be 2x plus 1 minus 6 all over 2x plus 1 plus 3. Now I can simplify those by just simplifying the top, 2x minus 5 and 2x plus 4. So my final answer here has a problem because there's obviously a denominator, and the denominator can't be 0. So 2x plus 4 can't be 0. So if I solve for that, 2x can't be negative 4, divide by 2, x can't be negative 2. If I plug in a negative 2, I will get an undefined value on my in my answer. Now I also have to check h of x, but h of x is just 2x plus 1. There's no fractions, there's no square roots, so in this case, that one's fine. So the only number that is bad is negative 2. So the way I would write my domain is I would say negative infinity to negative 2, parenthesis, because I don't want to include it, union negative 2 to infinity. So that's the way we kind of write the interval notation where we're just missing that one value. So there's a couple examples on the composition of functions and its domain. Please let me know if you have more questions.